Good afternoon and welcome to NASA's Kennedy Space Center for the Prelaunch News Conference for SpaceX CRS-12 to the International Space Station. I'm Joshua Fentz of NASA Communications, and I'm pleased to be joined today by Dan Hartman, Deputy Manager, International Space Station Program, Hans Koenigsmann, Vice President of Build and Flight Reliability with SpaceX, and Pete Hasbrook, Associate Program Scientist, International Space Station Program. We'll begin with opening comments from our presenters, and then we'll be happy to turn it over to you for questions. Dan, take it away.
Thank you, Josh. Good afternoon, everybody. It's great to be with you as we prepare for the SpaceX CRS-12 mission. As you know, we've loaded Dragon with 6,400 pounds of cargo, and I'm happy to say 75% of that total mass is headed toward our research community and our continued expansion of the research envelope on board the International Space Station. So with the internals and the external payloads that we have going up, it sets a new bar for what the amount of research that we've been able to get on this flight. Primarily driven because of our consumable levels are really good shape. Our system performance on board the International Space Station has been stellar. And so, you know, when we can, we try to dedicate as much as we can to the research community, and we'll be able to pull that off in this mission. The PIs and their teammates have been here for the last week preparing all their research in the late load categories for the International Space Station. I think we're just about getting ready to load all of our late load cargo into Dragon out at the pad. So that capability is just now starting, or that task is just now starting, and that'll all be in support of over 300 investigations we plan to conduct on the International Space Station over the next 6 months. 85 of those brand new. So very, very exciting times for our research community. You know, with the extension of PEGI, that gave us an extra crew of 4 crew members on the USOS side, and so crew time presently has not been a limiter in the amount of research that we can get done on board Space Station. And as we look forward to the commercial crew side, when we get a crew of 4 on the USOS, we're hoping that crew time constraint that we've always been living with for the past couple of years or so will be minimized or completely eliminated. So we're really looking forward to that. One thing with the launch tomorrow, this will be a 1 attempt. And so we could not, we have some other activities going on board the International Space Stations. The Russians have an EVA on the 17th. And so if we don't get off tomorrow and then launched on Tuesday, our berthing day would be the same day as their EVA, their planned EVA date. And we worked it out with the Russians that we were going to deconflict that, and so we would hop over that next the Tuesday launch opportunity. Then there's some activity here at KSC with the TDRS launch, and so it looks like our next opportunity for CRS-12 will be around the 19th, 20th time period, and so we're going to have to go work that out with all parties involved. But that's kind of what it's looking like right now. And so we'll have much more to say on that. Hopefully the weather will be just fine. The weather will cooperate tomorrow, and we'll get off the ground and be on our way with no conflict. So that's plan 1. Our crew is trained and ready to go on board. Jack will be prime on the Jack Fisher prime on the SSRMS capture. That'll occur Wednesday morning, bright and early. And then, as typical with SpaceX Dragons, we move that into Node 2 Nadir. Our planned hatch opening won't occur until the very next day, although I think the crew is aware that there are some frozen treats on this particular mission, so I wouldn't be surprised if they work long in the day and try to open a hatch and enjoy some, I'll say, well-deserved frozen ice cream, food, and frozen bars that we have on the mission for them. So we'll just see how that plays out, but knowing that crew, I can imagine them getting in, and we'll be ready to do that. The cream payload is in the trunk, ready to go. Somewhere in the first couple weeks of the mission, we'll pull that out with the SSRMS, the big arm. We then hand that off to the Japanese remote manipulator system, the GEM arm, and then our JAXA buddies will install that onto the exposed facility, and that's where cream will live for the next several years, conducting the research that it plans to do. Mission duration is a little bit over 30 days, and pretty much nowadays we let, the research side drive our mission duration. Obviously, we need to live within constraints of the Dragon. So this will probably be a little bit over 30-day mission to get all the research done and then returned home. Our return return cargo is also almost extensively researched. And so we're very, very proud of that. We've worked out with SpaceX. When Dragon splashes down, we get the Dragon back to the port, and we are actually turning over some portion of our early return cargo to the research community right there at the port, so then they can take it and start their immediate analysis of the results that they found. So overall, we're looking for a great mission and again, with a quick handover to the research community. We are working one issue on board International Space Station. It doesn't have an impact for the flight, but it's something you'll probably see us turn up our game. We have 2 S-band antennas, which is how we do command and telemetry with the vehicle. We have a RPC, which is the S-band antenna, and the equipment itself are just fine. We have a power control module that has been a little bit finicky over the last couple of weeks. We've closed it. It stayed closed. It's tripped. It stayed open after we tried to reclose it several times. It stayed closed for like 4 or 5 days, and so then it just popped back open last night. So we do like to have 2 strings going into a mission. We have that with our KU band capability as well. We can send commands, telemetry up that stream. So from a redundancy aspect, we're just fine for this mission, but it is something that we'll likely get the SPDM, Dexter out, get an RPCM from a location on the truss, swap that power module out, and be on our way. So it won't require an EVA. We plan to do that robotically, and we'll just have to figure out a time to go do that. Looking ahead as far as other major activities, as I mentioned, the Russian EVA on the 17th, that'll be with Fyodor and Sergey. They plan to retrieve some research that's out on their segment, as well as deploying 5 satellites while they're out on EVA. So they'll be setting those adrift overboard as part of their experiment. And like I said, they're going to be bringing in some other research from the mission. Peggy, Fyodor, and Jack, our 50S return is still planned for September 2nd, so we're looking forward to get them back. 52S launch on 9/13. That's with Mark, Joe, and Alexander. Everything is progressing well for that Soyuz launch. So again, we'll dip down to a crew of 3 for a while, and then we'll get right back up to 4 crew of 6, and four of those being 4 USOS crew members. So that'll really help us out from the research going forward, having 4 crew on board the International Space Station working on it from the USOS side. And then we have a progress launch on October 12th, orbital ATK mission. The 8th flight will occur on November 10th out of Wallops, and so we're preparing the cargo for that mission now. And the other thing is recently we decided to perform a triple EVA. And so that'll occur probably in the late October, early November. The content of those EVAs is still being finalized, but the main thing we plan to do is change out on the SSRMS on the latching end effector, which is kind of one of its base end. We'll end up swapping one of those SSRMS end effectors with one that is sitting out on the actual mobile transporter system today called the POA. And so we plan to swap those 2 latching end effectors out and then be back into a healthy condition. What we're doing, what we're seeing is a little bit of fraying on the snare wires associated with the latching end effector when it grapples over a grapple pin. And so we have plenty of margin, we have plenty of capability left. We just want to get out ahead of this in case we see some increased wear on it. So again, no immediate need, but it is something that we do want to go tackle. Again, we have the crew time in that time period, in the October-November time period. Crew will also be changing out a lot of lights and cameras on board the International Space Station and preps for the commercial crew vehicles that will be arriving, so we want to get those in good shape as well. And so we'll be, again, conducting those in a late October time period. Other than that, ISS is certainly ready to go for the CRS-12 mission. I think we're all going to be keeping our eyes on the weather, not only tomorrow, but also for the late load and pad activities that SpaceX has to do today. But we're ready to receive Dragon, and I'll turn it over to Hans for SpaceX status on the vehicle.
All right, thank you, Dan. So SpaceX is ready to go too. We had a good static fire, I think, on Thursday, and reviewed everything, all the data, everything looks pretty good, and so we're proceeding at this point in time. We're targeting a launch window at 12, 31, and right now 37 seconds. That might shift a couple seconds, just in case you ask. And then we're good to go on the 12th cargo mission here from this launch site to the ISS. So first stage will return to the LZ-1 landing zone, like the last CRS launch, similar. And I have some interesting statistics on our launches there. We so far had actually we completed 37 Falcon 9 missions successfully overall, and we landed 13 Falcon 9 first stage boosters at this time, 8 at sea and 5 at the landing zone 1 here at Cape Canaveral. So that's we got a lot of successful landings in the meantime. We still will say we attempt to land. It's still a maneuver that's audacious, I think is the right word maybe. And you know how it looks when those first stage are landing. But we certainly have a good number of first stages now that we are reusing more and more. Let's see. The trajectory and everything that on the flight is very similar to the last one. I don't think you will see any difference. It's a 200 by 360 kilometer orbit. Once we deploy Dragon is going to begin phasing with the International Space Station, and the berthing or grappling is going to happen on Monday morning in the early morning hours here at the Cape, and even earlier, I guess, in Pacific time. Wednesday morning. Yes, we launch on Monday morning, here Wednesday morning. Every time on these launch campaigns, I lose track of dates and times, and it just becomes an endless row of days. Thank you. Launching on Monday morning, Monday early afternoon, and berthing on Wednesday early morning. It's a pretty short phasing time this time. That's the only thing why I thought I mentioned it. And then Dragon is going to be there for roughly a month. There's a certain time frame that we can shift around a little bit, and it's going to return to the Pacific water there. We're going to grab it and bring it home to the port, and it's kind of funny because that actually happens to be a little more than a mile away from my house where the unloading happens. So I can almost see it. And that will be hopefully another successful CS mission. I would like to thank a couple teams and folks here, and in particular the SpaceX Dragon team and the SpaceX Falcon 9 team, which really did a lot of work over the past couple of weeks, getting Dragon ready, getting Falcon 9 ready, and getting the launch site ready. It's always awesome when it comes together in the days before launch. Then I want to thank the 45th Space Wing and the FAA for their support, and especially support on a Monday launch. That means working in the last couple of days too. So I really appreciate that. Thank you very much. And then of course NASA for being our customer and trusting us with their cargo to the International Space Station. Thank you very much. Thank you.
Thank you, Hans. Pete?
Okay, hello. Thank you for coming today, both here in person and the people who are out watching us on NASA TV and on social media. We're very glad to be here today to tell you about the important science that the Dragon spacecraft is bringing to the ISS, as well as the work that we're doing on the ISS. The Dragon brings us a variety of payloads, both in the pressurized module and in the unpressurized, as well as maybe most importantly, is bringing scientific samples home. Dan talked about the numbers. I have 2,200 kilograms of research hardware, or about 4,800 pounds of research hardware going up. That does include the external payloads. And then returning about 30 days later is about 1,200 kilograms, or close to 2,600 pounds. So over 2 tons of research hardware going up and almost a little over a ton coming home. So the space station is an international laboratory in space. It's multidisciplinary. It's much different than a lot of the labs that you would find here on the ground, which are focused on one type of research and maybe one specific type of research. We are multidisciplinaries. We categorize ourselves into 6 categories. We've got biotechnology and biology, earth and space sciences, physical sciences, human research, technology demonstration, as well as education and outreach. At any one time during the course of the year, we've got hundreds of experiments going on. Right now, I would put that number, somewhere around 250. The crew doesn't operate all those. A lot of those are being operated autonomously from the ground, and in a lot of cases, the crew are the subjects in the case of human research. To date, with the ISS program, in the 16 or so, 17 years that we've been permanently occupied, we've had over 2,300 different experiments, investigations that have gone on the ISS, including the shuttle missions that brought science to us. We've had over 3,300 different scientists from around the world participate, and we are somewhere around 100 countries that have participated now. And our goals with ISS research are to advance the knowledge of the natural world around us, to enable future space exploration. We are now expanding the commercial market in low Earth orbit, not just by commercial companies launching to us, but providing hardware and partnering with our scientists. And generally, overall, we are working to improve our life here on Earth. I'm not going to talk too much about the science today, and I hope you'll come back and join us at 3:30 Eastern Time. We've got several scientists coming to talk to us, both from the NASA side and the National Laboratory side. The first up, you'll see 2 scientists from the Michael J. Fox Foundation talking about Parkinson's disease and their work to crystallize a protein crystal, an enzyme that has been implicated in the spread or the development of Parkinson's disease. And by growing a larger crystal in space, which you can do in microgravity, things grow larger and purer, they're hoping to get a good understanding of the structure of the crystal so that they can understand the pathology of the Parkinson's disease as well as potentially develop therapies for treating it. We have another scientist who will be talking about growing lung tissue in space by steering stem cells to develop into lung tissue. The benefits there are to hopefully be able to grow bioengineered tissues that will help us with replacing organs on the ground, repairing damaged organs. Dan mentioned the CREAM experiment. We officially call this the ISS CREAM, or maybe the ICE CREAM. Cosmic rays and energetic particles is what it measures. It goes outside the space station, measuring cosmic radiation, which comes to us from all over the universe, as well as other charged particles. It'll be launched externally in the trunk of the Dragon and then installed on the outside of the space station. This is a good example of using the ISS as a platform that's already in space and gives services. The CREAM experiment has launched several times on high-altitude balloons, been very successful there. They're just adapting the instrument and bringing it to put on the outside of the space station. We provide power, data, and other services in the platform in space. Next, you'll hear about the science going on with the rodent research mission, the next one for NASA. This is a research team of scientists looking at rodents that will be on the ISS for 30 days and then brought home live, and how they develop in space. Rodents, model organisms for us, their lifespan is faster on space, and we'll see how they adapt, and especially this team is looking at visual impairment and the fluid shift and intracranial pressure that has been observed in humans. We can learn by studying rodents in that sense, as well as bone structure, so hips and knees and the bone joints. You'll then hear about a microsatellite, a technology demonstration that will be using a small satellite in low Earth orbit that is able to be commanded and requesting imagery for someone who's on the ground, and that communication path does not need to go through geosynchronous satellites. So it's a test of commercial off-the-shelf experiments and has some good applications on the ground for us. And finally, maybe the most fun one that you'll hear is a group of Boy Scouts here from a troop in Palatine, Illinois, partnering with NanoRacks, looking at cell mutation and how microgravity is going to increase the rate of mutation. So some really good stuff going on coming to us for the SpaceX Dragon launch tomorrow. Other good things going on in the space station program. Dan mentioned research, and he mentioned, for example, Peggy Whitson. Her stay was extended because of the availability of a seat on the Russian Soyuz. So her extension by 3 months has brought us to 4 crew members earlier even than we were expecting. What that does for us is it essentially doubles the amount of crew time that we can get from our ISS crew to devote to science. We already had all the medical and the maintenance and the systems and stowage covered, so that additional crew member is, that time all goes our way, goes to science. With the launch of the Soyuz coming up in September, that will continue our series of having 4 USOS crew members. That arrangement goes for sure through next summer. And then, like Dan said, we're looking ahead to the time where the commercial crew programs will be bringing U.S. crew members for us. So part of the message there is we've got plenty of time now to do the things that we want to do on station. If you're a scientist, we want to hear from you because it's a really good time to come back and work with us. There's some other things going on in the science world at NASA as well. Hopefully you've heard that there's an eclipse happening a week from Monday, excuse me. The ISS crew is going to be able to see that eclipse as well. They'll be able to see it from 3 consecutive orbits. Their first orbit, they'll be flying over the Pacific Northwest. The shadow will not be on the ground yet, but they'll be able to see a partial eclipse as they go by. The second orbit, the crew will actually be orbiting up over Canada, but they can look toward their southern horizon. They'll be able to see the shadow on the ground somewhere around Kentucky and Tennessee. And then on their third orbit, they'll actually be able to see the most of the eclipse of their 3 passes. It'll be about 85% that they'll be able to see. The crew will have special filters and special cameras to look at the eclipse, and if you're going to look at the eclipse, you should have those things too. There are tips for viewing the eclipse on NASA's Eclipse website. It's eclipse2017.nasa.gov. And finally, a little bit of excitement right here. We're all hoping for clear skies tonight as well. We've scheduled a really good ISS pass to fly over Canaveral and KSC tonight. So about 9:33 p.m., be looking northwest, be looking for something that looks like it might be an airplane on the horizon. It will grow, and this one's going to go almost straight overhead. After it goes overhead, it will disappear into the ISS sunset about 200 miles above us. So back to the purpose, though, of the briefing today. SpaceX Dragon, we're really excited about all the science that it's bringing and it will bring home for us. And we're excited about all that's going on in the ISS as well. So thank you.
Thank you, Pete. We now have a brief weather update for you from the 45th Space Wing Weather Squadron. Winds tomorrow are expected to be around 10 miles per hour. The temperature around 85 degrees. The only concerns for launch tomorrow are the cumulus cloud rule and then flight through precipitation. The potential of violation is about 30%, meaning that we are 70% go for tomorrow's launch. We'll now take your questions beginning here in the room at Kennedy. If you would, please raise your hand, state your name and affiliation, and to whom you're directing your question. We'll begin in the front here with Marcia.
Marcia Dunn, Associated Press. I think for you, Dan. Peggy Whitson's extra 3 months, how much has that pushed the boundary on what you're learning about long stays in space? And do you have an idea of when the next long-term astronaut might be? I mean, when's the next? Is 1 year cruise still in the picture, or how's that all?
Sure. Even Pete could help chime in as well, right? So from a agreement with our Russian colleagues, those discussions are still ongoing. We don't have an agreement in place for additional crew members to stay 1 year. We are certainly pursuing that, though, with them. And as far as Peggy, I don't know if we really set up, in advance the 1 year protocols that we're looking to do. So the teams have been able to adapt to those as we've gone from 6 months to 9 months to 10 months kind of thing. And so just more data points on things like bone densities and certainly all kinds of biological samples being taken that the crew member, our research teams, human research teams on the ground will be able to analyze when she gets back. Pete, anything else to?
Sure. Yeah. This is a good windfall for us as well. Peggy was already a subject in the fluid shifts experiment, which was one of the key experiments in the 1 year mission that Scott Kelly and Mikhail Kornienko did. So with her duration now increased, she's now on the same scale that they were. Not quite as long, but we are continuing her fluid shifts sessions. She's also continuing some of the other science that applied to the 1 year mission, behavioral, food surveys, all of her biomedical data, biomedical research can be applied as well.
Do you have to have a Russian partner with this, or could you just send up an American all solo, or 2 Americans, or a European? I mean, why do you need to have the Russians sign off on this?
Well, certainly during the periods of Soyuz, that would be the case, and that's how far we've, from a near term, that's where we've looked. I don't know if we really had the discussions once we get into I'll say, routine services with our commercial crew programs, if we can do that solely on our side. I would imagine that answer would be yes, but I have not been involved in those discussions. But I can't think of anything that would preclude us in that regard.
And we'll stand in front of the room here.
Chris Gebhardt with NASA Spaceflight, with one for Hans and I believe one for Dan. For Hans, with only 1 day in a window before having to stand down for a week, can you talk a little bit about what the teams did to fix the computer issue that stopped the Intelsat countdown at T-minus 9 seconds twice? And for Dan, is it the science experiments on Dragon, or is it the need to catalog the satellites that are being deployed during the Russian EVA? For why Dragon only has a day. Basically, why can't Dragon just launch and loiter behind the ISS? Thank you.
So regarding what stopped the Intelsat launch, like 9 minutes, I think, or 9 seconds rather, before T0, those computers are ground computers, and they're driven by a certain script that checks for values, and we clip those values in this case, so those are things that are relatively easy to fix, and had been fixed basically the day later, right away, and tested again. I don't anticipate that to be a problem, although I shouldn't really say this. Knock on wood. I'm actually, when I think about what I'm worried the most, is actually weather right now. The weather is right on the. I know it's 30%, but those percentages. Change in the hour before, and even if you're stuck within those 30%, that be not good. Having said that, I think everything else looks pretty good. As Dan said, late load should get going by now, and we double-checked everything, triple-checked everything. Among those checks is also another check for those abort files, of course, and so I'm cautiously optimistic, I would say, for this one launch opportunity, and better one than none, I would say, and we'll see how it goes.
And Chris, as far as the next launch attempts, right? So if we couldn't get off tomorrow, we had to go on Tuesday. That would line up the birthing day on the same day as the Russian EVA. So that was out of the question. We pursued that with our Russian colleagues, and then you hit it, right? Then the Russians on that EVA deploy 5 satellites, and we do require good tracking on those, so we know where to go. Fly Dragon, help SpaceX fly Dragon when it's approaching into the ISS. So that's a big deal for us, obviously. Could we loiter? Yes, at the expense of losing research, because they time, their samples have X amount of hours before they need to be offloaded, brought onto the station, and so we looked at that as well. And the loiter duration once around, bringing it back in, just didn't solve didn't close on some of the research parameters that we had. So then you get into past that, you have TDRS on the 18th with a backup day on the 19th, and so that's kind of when at least when we look at it, and at least from a compatibility with the station, that seems to play okay. Whether we can get range, SpaceX, I mean, there's a lot of things to do there. But as far as the station program, we look like those are acceptable days.
Bill Jelen for We Report Space for Hans. The half fairing that you caught, recovered at sea, have you started processing that and learned anything from that? And would there ever be a time where you'd actually send a ship out to try and catch the fairing even though you're landing on land?
I think there was one case where we had that case that you just described, yeah. So we learned a lot over the last fairing landing test, I would say, and the fairings have little thrusters that help them orient for the reentry, and we find that obviously. Then they have a parachute that opens, so we worked on that too. I think we still have to learn a little bit to actually land them and recover and reuse them at this point in time. But it's certainly something we've made great progress over the last couple of months.
So will there be another attempt to
Well, not on this one. I mean, obviously this one doesn't have a fairing. The next fairing mission is the one after that, and I think it has an attempt.
Thanks.
I
We'll now
think
go
so.
to Bill.
Hi, Ken Kramer, Universe Today and Northeast Astronomy Forum. Two questions. One about cream, if one of you guys can answer it. Why is it on the gem and not on the truss or somewhere else? And for Hans, can you give us an update on the two pads, 39A, preparing that for Falcon Heavy, and 40, preparing that for first flight? And when might we see a first flight again from pad 40? Thanks.
I can take a shot at cream, and Pete, you might want to, from a science aspect, you might want to chime in as well. But the Japanese exposed facility has an accommodation as a cooling loop, all right? And in all the truss sites, or the payload sites that we have on our truss segments, on our ELCs, don't have that. The Columbus external sites don't have that. So there's a unique capability, I want to say, on 8 of the 10 GEM exposed facility sites, where it actually passes, I think, a floor inert fluid, acts as a cooling agent, and so you can get a lot more heat dissipation and get your temperatures up and take that heat away with, and then that cooling loop gets routed back inside into a heat exchanger and is brought out onto their internal GEM control system, and then we dissipate that heat out through our big radiator. So believe it or not, the cream payload out there is actually tied into our main radiator systems out on the truss segment to give them and it's a capability to give payloads that need the power some extra cooling capability. And from a research side, I'm not quite sure.
Say what Dan said.
Yeah, okay.
We also look at these various sites at the field of view that they would see, and CREAM needs a wide sky. The GEM does a pretty good job. I think the site that CREAM is going to, or ISS CREAM, we're supposed to say, as opposed to balloon CREAM, the site on the GEM that it's going to has a decent view, but it's also one of the few that can accommodate that big of a payload, that heavy and large of a payload mass.
Do you mind repeating the question?
Yeah, sure. Can you give us an update, please, on pad 39A, preparing that for Falcon Heavy and removing the RSS, and pad 40, getting that ready for the first flight, again, of Falcons from there, and which flight might it be, CES or what? Thanks.
Yeah, so I should have driven by 40 this time. I didn't. I mean, obviously, we'll be making great progress on 40. The cutover time has to be scheduled such that there is no delay from one pad to the other, obviously. And then, you know, as you pointed out, we need to actually do a couple additions, I would say, that we already have in work for Falcon Heavy to get Falcon Heavy ready. So in terms of time frame, I think this is in fall this year going to happen. And I don't think it's the next GEO mission. It's one of the next GEO missions that might be the first one from 40 is the old one, right? Yeah, from 40. So, but I'm not sure exactly which one. But it has to happen in the time frame of you know, fall, October, November to get then ready for Falcon Heavy at the same time.
And if we can now go to the back of the room to Bill Harwood.
Bill Harwood, CBS News. For Hans, are you just as gloomy about the Falcon Heavy as Elon was the other day in his text? But seriously, I mean, you're the engineer. I'm one of the engineers. I'm asking, maybe give us your assessment of what some of the challenges are of making that rocket work.
Well, it's a big rocket, and there's certain elements that we haven't done so far. We haven't. I mean, we've done lots of models and analysis and all these things that you do for booster separation, but then the actual booster separation, you know, is it really going to work like we analyzed and modeled it? Yeah, I don't think I'm that gloomy, frankly, and I think we have a good shot at it. Obviously, I think it's also just to let people know that there's a difference between an operational vehicle like Falcon 9 and a maiden flight of such a big, massive rocket. It's 2/3 the thrust of Saturn V, and it's going to be, I think it's the biggest operational rocket at that point in time then. So there's certain things that are just unknown, uncertain on the first flight, and I think Elon just wants people to be, I guess, cautious on this particular flight, on the first flight. And it's also, one effect is obviously that the engineers at SpaceX just double up and review everything even more and make sure that it doesn't happen. Yeah, it's the opposite of complacency in that case. It's really just make sure that everything is done and everything is ready. I think that is his intention with that, basically.
Hi, Stephen Clark from Spaceflight Now. One for Hans and one for Dan, I believe. For Hans, are you flying anything new on this booster to aid in refurbishment and reuse? I know you introduced the titanium grid fins a couple of months back. Anything new in the heat shield or anything else on this mission? And for Dan, do you have a specific date that you're targeting for Dragon departure and splashdown for this mission? You said about 30 days, but is there a date out there? Thanks.
Your first question is really almost in the weeds for me. There's always details where we test certain materials or something like that, and there's a good chance that this is on there too. I don't know exactly the details on that. There's nothing massively different on this booster compared to the other ones, so from that perspective, I don't have that in my head right now. Sorry.
Mission duration from our research community, the last I heard was 35 days. So can't do that. Now, I don't know what that translates into September, but 35 days plus launch is where we'll be.
Just throw a quick one while the mic's still here. For Hans, I've noticed the RSS, we've all noticed you guys are really taking the RSS apart. What is the schedule for that? When would you expect that to be completely down?
I want to say it's largely driven by how the work progresses. I don't think there's a specific schedule. We take it take it carefully down. I mean, obviously we got to close the area when we work on it, and while we are launching, that may not always be possible. So I don't think it's a top priority. And everything that we take down, by the way, goes to NASA. So it's not something that we sell as scrap or anything. It goes back to NASA.
And let's see, I just looked at our flight plan. So they did have a specific date on there. So we launch, when we berth 8/16, that would get a return on 9/17. Mm-hmm.
We'll take one in the front of the room, and then we'll go to the phone bridge.
Robin Simangle, Wired Magazine. I have some questions about the CRS-11 Dragon. Did it really cost as much to refurbish it as it would have taken to build a brand new one? And how are you guys moving forward with refurbishing future Dragons, and will CRS-12 be the final flight of a factory fresh V1 Dragon?
So the refurbishment of CRS-11, the last one basically, it doesn't cost as much to refurbish it as to build it new. That much is clear. Otherwise, that'd be very wrong. and the first refurbishment by its own is typically a little bit more expensive because you need to look at stuff, you need to make a decision, you need to find out which is critical components and which are critical for refurbishment, and which are components that are not attached by seawater, for example, is always an issue. Yeah. So obviously, we expect the refurbishment costs to come down over time and to be a lot more advantageous than this particular first one too. Yeah, and then regarding the future Dragons, this is something we talk about with NASA right now. So I don't think we've settled on everything here, and so over the next couple of weeks and month, that's something that we will determine. But from the SpaceX side, that would be great if we had a chance to that this one would be the last new Dragon 1, I think I must say, and then from then on we reuse them. It has been built and designed for multiple reuse. There's no question about that, and that is something that we always strive for, to use parts again and get more towards an operational concept like an airplane, basically.
We'll go to the phone bridge, and then we'll take some more in the room. We have Mark Gotch. Mark?
Yes, hello. Good afternoon. Mark Gotch, Historical Aerospace News Media. Once again, thank you for your informative briefing this afternoon. A two-part question for Hans. Hans, can you tell me, on any mission, what is the maximum payload capacity in pounds in terms of weight for the Dragon capsule? And based on this CRS-12 mission, with its important payload of such important research experiments and supplies to ISS, what is the maximum weight of this mission? Thank you.
All right. this is off the top of my head and not necessarily accurate, yeah. But I think I saw a number yesterday that's 10,600 kilograms for the entire Dragon. And in terms of, is this a heavy payload, a heavy Dragon or not? I don't think it's a heavy Dragon.
I think it's our heaviest.
Yeah, we had heavier Dragons.
In fact,
right?
what I'd say is on this one, it is one of our heavier ones, but we're also internal to the Dragon volumetrically full. So it depends on
Right.
density of your cargo as well. So we're flying what we need to fly. Some of it, and like I said, we volumed out before we massed out the total capability, but it is exactly what we want to go fly. So sometimes mass isn't the metric to use,
Yeah, sometimes
is
it's
my point.
volume.
Yeah.
Thank you.
Julie Hayes with the CBS in Waco, Texas, just about 10 miles down the road from the McGregor testing facility. And Dan and Hans, this is for the both of you. First of all, if you could just tell us more about the relationship between NASA and SpaceX, how that is, and also how critical is a facility like McGregor to accomplishing your overall goals?
Yeah, the relationship is grown immensely with respect and sharing of information and knowledge transfer, quite honestly, both ways, right? A little bit new way of doing business with SpaceX. It's really forced us to come back and look at our processes. And it's somewhat turning over the keys to a commercial industry to take over, not take over, but to get mature and the ability to perform commercial markets in low Earth orbit, right? Our goal will be to eventually get out of low Earth orbit, get on our way to cislunar onto Mars. And so we want to leave behind the knowledge that we've gained for all these years to the SpaceXs of the world, to the Sierras of the world, to the orbitals of the world, so they can pick up and hopefully we'll see, you know, in the next 5-10 years, somewhat of a more even vibrant commercial market in low Earth orbit, which can be self-sustained. You have commercial launches, commercial crews could be possibly going there to low Earth orbit. Again, thinking past when the ISS is done, you know, we want to be able to, I mean, I think it would be good for the nation, good for the world if we carried on with some of the fundamental research that we're doing in low Earth orbit. We plan to leave that to the commercial markets to do that.
Yeah, I would say SpaceX and NASA at today works as a team. There's things that SpaceX can do very well, and there's things that NASA can do very well, and anything that is related to knowledge that we have not done so far. NASA has enormous resources that help us, finding how to solve problems and how to get stuff done, and in return we really enjoy launching their payloads and cargo up to the station and also satellites. That's obviously great to have NASA as customer there too. And with respect to McGregor, it's essential, absolutely. I want to say it's one of our key important facilities, as important as the launch site, I would say. We test every engine there. We test the engine at basically the environment where they're going to be tested, and then we ship the engines back, build a rocket out of it, and then ship them back to McGregor and test the entire stages. And that is something that not everybody does. That is something that really helps us to become reliable. And the McGregor facility allows us to do this. It's something you can't do in the middle of Los Angeles, obviously. You need a facility out in the open. And I was actually on the team that went originally to look for test sites 15 years ago or 14 years ago. And I do remember swinging by McGregor and thinking, okay, this is the place. This is where we build our test site. And today it's a really busy site. There's I don't know how many hundreds of employees by now, and it's a very professional and built-up site that is absolutely essential for us and for NASA too, actually. So
We'll stay here in the front of the room.
Thank you. Sawyer Rosenstein with Talking Space. For Dan, I was just wondering, because originally we had heard an October date, I believe, for the next Cygnus launch for OA8. Can you talk about what the future is for the rest of the year for cargo resupply missions, and if having 4 USOC crew members is affecting that, either needing more supplies or no difference at all?
So from a CRS mission, so SpaceX obviously this 12 one. Then 13, we're hoping to get off, I'll say early December time period. The OA8 moved from October to November. And a couple reasons on that. Number one, we want to get these EVAs done in front of that. And so that gave, again, kind of a, and you kind of want to do EVAs consecutively to make the best use of the crew time and how much refurbishment you have to do with the suit between the EVAs. So that was a driver. Actually, we were a little bit light on the OA8 mission, and so with the slip of 1 month, we were able to produce or get new cargo that we need up to the station on the order of about 400 kilograms. So a significant increase in the amount of mass we could take up for it. And then also, you know, kind of like we have the Dragon, we try to really use the Dragon for return of samples and, you know, for the research community. The Cygnus vehicle is a tremendous disposable cargo hauler. I'll put it that way. Trash is another word for it, right? But so we try to figure out where to space those based on trash generation on space station as well. And so, and I'm trying to think ahead. I think the next orbital mission was, I think, in the March time period. And so we're trying to figure out, you know, spacing-wise, trash accumulation, and when we should put those orbital missions in place. You know, it's just, it's another factor of where we come to place the launches when we do. But from a spares, from a food, from a water supply, we could accommodate. Our consumables are in very, very good shape on board the space station. So the slip there will basically have no impact to our crew of 4.
We'll go back to Marcia.
Marcia Dunn, Associated Press. Question first for Hans. What do you see as the biggest hurdles to make a November launch date for the Falcon Heavy? And then I have for Dan, the ice cream bars are going up in a freezer. Is there signs going up inside of that too, or is it just going up empty to bring stuff back? I just wanted to clarify.
Biggest hurdle for the November launch date of Falcon Heavy. Well, if I know the biggest hurdles now, then I would actually actively working on it. We would throw resources at it, and other hurdles would become the biggest hurdles. And these are big projects. I would say it has to be both working on Falcon Heavy and on the LC-40 side. So in other words, LC-40 needs to be ready before we can switch over. So those are 2 major projects at this point in time. We had a chance to make really good improvements on LC-40 and get a lot of the automation and redundancy that we had on here on 39A also into 40. So that's definitely a much better path than it was before. And so we got to get this up and going, and then likewise Falcon Heavy, it has complexities. Obviously, it's a big rocket, 3 different rockets together basically, and so that needs to be done too. Maiden flights are hard to plan. I mean, we plan them obviously, and then there are concerns that need to be addressed and hardware that needs to be tested. And that's where the uncertainty comes in. But overall, I can tell you it worked pretty well in the last couple of months on Falcon Heavy and both the LC-40. So I think this you have a good shot at it.
And as far as the other goods, it's a pretty, I'm not gonna say challenging job, but when you try to figure out how much cold research you're gonna go fly, either in freezers or in cold bags, and then you work on their temperature variations that they need and their durations. It's an iterative process, and you try to figure out amongst all of our assets that we fly up, which are several types of freezers and cold bags, how they best fit, pack-wise, and meet all the requirements. And at times, we have excess volume based on, we could accommodate all of our requirements, and we had some excess volume. And I think in this particular case, we have more than the usual amount of ice cream products going up in one of our cold bags. I'll put it that way. So we did pretty good. They'll be happy. They'll be happy. They'll be happy.
So it's not sitting alongside experiment stuff too. I
No.
mean, it's just.
If it would, we would do all the proper containment
Yeah,
and
okay,
separation. So
And I'm
yeah.
sorry, did you say cold packs or is it an actual freezer?
I don't know where. Maybe Pete, we have cold bags, which you kind of put ice bricks in, frozen bricks that kind of keep it the temperature inside the cold bag cold, or we have active refrigerators. In this particular case, I can't remember.
Yeah, the other thing that we've had going on, we've had a couple of our freezers fail on board recently. So it may be that these are spares to go up to replace the ones that we're using. So there you've got capacity as they're going up.
And if we could go back to the second row.
Excuse me, Tim Fernholtz from Quartz. A couple times today we've mentioned the importance of late load to the scientific research mission. I'm just curious if Hans, you can talk about the engineering and operational challenge of delivering that capability for NASA, and maybe Peter, Dan, why that is so important to your work.
So you want to go first? Or?
Well, I'll let Pete take over
Pete,
late
you want-
load. I mean,
Yeah. Okay, I go first. So, from the engineering perspective, it is basically a clean room with a no, what's it called? Forgot the intermediate room where you.
An airlock?
An airlock, yes, exactly. where you basically pass stuff on, and then if you load it in particular into Dragon in the horizontal phase, you got to have the equipment to push heavy items up and then move them in around in Dragon. So that I think is the main engineering challenge. Yeah.
And then scientifically, a lot of the things that we study are biological in nature, either alive or need to be activated. If you're studying a yeast, you want to put it in maybe as close to launch as you can. We just talked about some of the cold stowage capability. If you're using a cold bag, which may be kind of like a cooler as opposed to a refrigerator, that's got a lifetime until the phase changes and it's not keeping it cold anymore. For example, another example is the rodent mission. We have to load them late in the flow. That's another reason that we wouldn't launch and have loitering until after the Russian EVA, because they've got a certain amount of food in those transporters. They're transported a little more densely than they are in the habitats on station. So you have to think about, I'll say, expiration of your science. If you start plants growing and that, a plant growth experiment is important to you, you don't want them growing for 3 days on the ground as opposed to the time and space.
Is there even roughly like a last minute where after that late loading can't happen? Do you have a sense of what the time before launch would be? For anyone?
Yes, a cutover, right?
it's when you go.
It's when we want to go up and start filling gases and fluids.
Yeah.
In terms of timeline,
I don't know. I don't know. I won't even hazard a guess. But it's a tremendous capability, right? We process all these over in the SSPF, where we process all of our truss elements. We've got refrigerators and clean rooms. That's where we house all of our principal investigators. And then it's where we do all the packing. We then carry all those out in vans, literally right up to the pad. And then they have a airlock that is actually, the hatch is open to the Dragon, and guys are just basically, bolting payloads, physical mid-deck lockers in place, hooking up umbilicals. In the meantime, everything that's not is still in the van, nice and cool and fresh and everything. And so, how they've choreographed that over time has been phenomenal. And I would even say on the return as well, right? When we get to the port, it doesn't take very long time for us to actually get it off the Dragon into a principal investigator's hands right there at the port, and then they're off and running with it. It's great. It's a great capability.
We have a question back with Jason Ryan.
Thanks, Stephen Clark from Spaceflight Now. Again, one more for Hans. Once you do get Pad 39A available to start working on it for the Heavy, what exactly do you have to do with the pad? You said there were a couple of things. Is it stuff on the transporter strongback, or is it something in the hangar, or what do you got to do? Thanks.
So one difference is obviously you have 3 holes on the launch mount and not just one right now, and there's so that has to be adapted to Falcon Heavy. The hold downs, the way that the things that hold down the rocket are triplicated and slightly differently arranged. Those have to be they have to be integrated and tested functionally. Obviously, more fluid. That capabilities is already there and has been worked on, and I think all the elements are ready to go. It's a matter of putting it together and then testing that it's functioning properly.
And I believe you have a question on the third row. and we'll come back to the first row.
Alina Schadwinkel, Zeit Online Germany. I was wondering, maybe the question was answered, I'm sorry. Is there anything reused on the Falcon 9 that's going to launch tomorrow? Question for Hans.
Yes. The landing legs are reused.
We have time for one more question in the room, so we'll go right back up to the front row.
Chris Gebhardt with NASA Spaceflight. Once 40 is back up and running, are you maintaining the ability to launch the cargo Dragons from both 39A and 40, or are all Dragon missions shifting to 39A?
I hear your question. It's an excellent question. I don't think I have a good answer for you today. It's something that we need to work out on how we split the missions and where we go from what path. It's actually a really good question, yeah.
Thank you very much for joining us today. That's all the time that we have. A reminder that SpaceX CRS-12 launch is scheduled for tomorrow at 12:31 p.m. Eastern Time. NASA television coverage will begin at noon. Until then, you can follow more about the launch on nasa.gov/SpaceX, and then tune in again today at 3:30 for the What's on Board science briefing. Thank you very much for being with us.